Alright guys, so what this video is going to be on, it will be on more complicated rules. Well, the same rules of exponents, just more complicated problems. So if you look here, we're going to have x to the fifth over x to the second, y to the third over y to the, we'll say fourth. Okay. If you notice here, it is a different quotient rule problem. There's only a quotient rule in it, nothing else. So if you look here, we have an x and an x. Two bases that are the same. X to the fifth is numerator, x to the second is the denominator. Since the larger power is on our numerator, the answer of x will be on our numerator. 5 minus 2 is 3. Likewise, since this is a 3, the larger power of the y is on the denominator. 4 minus 3 is 1. Answer. It's cool. It's good stuff. I like it. So, what am I going to do now? Let's see. Alright, let's do 4 over 5 to the negative second power. Okay, so basically we have two rules combined into one. We have raising powers to a power, but we also have a negative exponent. Okay, what I like to do with these is I like to get rid of our parentheses first. So since both of these have an exponent of 1, we need to take this negative second and bring it inside the parentheses. So when you bring a power to a power, like in the last video, you multiply. So we have 4 to the negative second over 5 to the negative second. Now the next rule we can justify or take care of is the negative exponent rule, which means that if you have a negative exponent, you must take the reciprocal to make the exponent positive. Since it's 4 to the negative second on the numerator, that bad boy is going to go to the bottom. And 5 to the negative second on the denominator, so he's going to go to the top of the numerator, like that. Okay. Then when you simplify, we have 25 over 16, which is your final answer. All right. It's really nothing crazy once you break the rules down. They just kind of, I don't know, they're pretty simple. I like them. You'll learn to love them too, I hope. All right, the next one we can do is let's do, oh, that's not straight at all. Alright, let's do a tricky one. We have x squared, y to the negative 3, z to the 0, over x to the fourth, y to the second, and we'll leave it as that. And then just for fun, let's raise it to the second power. Okay. Like I said, I like to get rid of the parentheses first. There's various ways you can tackle this. I just like to get rid of the parentheses. So let's take this 2, and we're going to send it into the inside the parentheses. So every single arrow represents multiplication. Okay. So we are left with x to the fourth, y to the negative sixth, z to the 0, because 2 times 0 is 0. X to the eighth over, and then y to the fourth. Okay. So we are going to have x to the fourth over x to the eighth, y to the negative sixth over y to the fourth. Okay. I'm going to combine some rules here. I like to do the quotient rule. So if you notice, we have x to the eighth and x to the fourth. X to the eighth is the larger exponent, so our x answer is going to be on the bottom. 8 minus 4 is 4. Now when you look at the y's, you would say 6 is a larger number than 4. However, when you bring the negative sign into it, 4 is the larger number. So we are going to subtract 4 minus a negative 6, which is going to give us a positive 10. Don't fall in the trap of forgetting how to subtract negative numbers. There's another way you can do this one, but I like doing it this way with the quotient rule. And then z to the 0 just goes to 1. And there is your final answer. Alright, here is 3 problems that combine some of the exponent rules, or rules of exponents. And like I said, I know I go fast, but you can slow me down, you can rewind me, you can stop me. Do whatever you like. So, And that finishes rules of exponents.